りがとうございます。皆さん、こんにちは。I'm Edson Yanaga, and I'm a developer advocate for Google Wallet. And today we're going to cover revisiting design patterns after 20. And just as a curious fact, who here has an iPhone?
iPhone をお持ちの方。
iPhone? Who here has Android? Good, すごい. And so I chose to talk about this subject, and I'm going to speak very slowly to try to make it easier, because this book was written more than 20 years ago, and we also had Java 20 released recently. So that's why the title is After 20. And a lot of the content from this book was super useful when it was written, but more than 20 years later, we have different tools, different patterns that we can use with our code. So it's time to revisit how can we implement some of these design patterns. And some of the ideas that I took for this talk are also coming from domain-driven design. At least one pattern is coming from this book. And of course, other ideas are also coming from book Effective Java. Java 20 was launched on March 21st, 2023. And to give you some more context of what we're going to try to explain, I emphasize in bold here that a design pattern is a general, reusable solution to a commonly occurring problem within a given context, which means that design patterns can be reused in many different places as long as you understand what is the problem that we're trying to solve and what is the context. Because using a good design pattern in a bad context leads to a problem, not a solution. And design patterns are also good because it brings us a pattern language. Now when we want to explain a solution, we don't need to tell people that, we need to create an interface with multiple implementations, so I can switch the implementation just by changing the instance that I'm using in a certain class. I just explained the strategy design pattern. So now I can just say, well, let's use a strategy design pattern instead of trying to explain the solution in this context. So a pattern language helps developers to create better code. And some of the guiding principles that I brought to give the revisited version of these patterns are: first, this one from the original Design Patterns book, favor composition over inheritance. So instead of trying to create hierarchies of classes, we're going to compose objects one inside the other to create solutions. Second, this one is the interface segregation principle. Favor smaller interfaces. Instead of have big interfaces with many methods, we're striving to have smaller interfaces, ideally with only one method. And favor existing interfaces. This one is from Effective Java. So instead of creating new interfaces in your code, because every time you create a new interface, a developer needs to look at the interface and try to understand what it does. But since Java 8, we have almost 40 functional interfaces that we can use from the JDK. And now that it has been a lot of time since Java 8, a lot of developers already knows what those interfaces do, like function, like consumer, like operator, binary operator, and other interfaces. So we already created a pattern language based on those interfaces. So we should try to avoid most of the time to create new interfaces. So favor existing ones. And based on these principles, what I'll try to show you, if we have enough time, are these revisited design patterns. So we'll try to explain command, observer, strategy, template methods, singleton, interpreter, chain of responsibility, visitor, and specification. It's a lot, but just in case we don't have enough time, all the source code from this presentation is available on GitHub. So I'll share a link later. You will be able to check the source code. First, commands. Commands, in the past, we used to create this interface for the command design pattern. We have public interface command and one method execute. Well, we already have a similar signature in the JDK, and it is runnable. So instead of creating new command interfaces, we should be reusing the runnable interface. Next one is observer. For observer, we used to have this one, observer and notify of type T event. Since Java 8, we also have consumer, which has the same signature and same type. And we have an observable implementation in the JDK, but it has a lot of bugs, so it should be considered deprecated. So if you want to create the observer pattern, the observer interface should be a consumer, and the observable implementation, you should create one by yourself. The one in the JDK is not thread safe and doesn't have a guaranteed iteration order. So that's why it's a bad one. You should create one with the requirements that you have in your code. Now let's move to the more interesting one, strategy. So to show you the strategy, I'll show you some code. So before, for us to create the strategy design pattern, is it good in the back? Can you see?
後ろの方で大丈夫です。
So here, we used to create an interface with one method, and we would need to create concrete implementations, right? So I have here two different implementations for this. And when I'm creating here an instance, I want to change the strategy. For example, in Google Wallet, you have two different ways of creating a pass. You can create a complete one, or you can generate a pre-created code. So I can change that at runtime just by changing the instance. So here, when I create a new instance of Google Wallet endpoint, I can change the implementation. This is a complete one. I can create for a pre-created JOT strategy, and it's done. This is the legacy one. Now, if you want to do the new version, instead of creating a new interface called Add to Google Wallet strategy, I can simply, in the endpoint, I can create a function which receives pass information and returns a string. Look at this one, this function, and look at this Add to Google Wallet strategy. Same signature. I'm receiving a pass information and returning a string. So instead of creating a new interface, I'm using one from the JDK. I'm using a function which receives a pass information and returns a string. Okay? No need to learn a new interface. And when I have a functional interface like this one, if I want to invoke this code, I can do interesting things. For example, I can use a Lambda set function. I can say, well, I'm receiving a pass, and I want to return a string. So I can create codes like this using Lambda. Or I don't need to create concrete implementations for each one of the variations that I want for this code. I can create, for example, one single class with all the methods, and this is complete. This is pre-created. No need to implement the interface because I can use method references. I can use this one, set function. I can call this class, add to Google Wallet, and using this method, complete. Same thing as before, or I can do this. This is a static method. That's why I can do this. But this is not static. This is an instance method. So I need to create like an object. Recreate it. Okay? So this is the modern way of implementing the strategy design pattern. You don't need to create a hierarchy of implementations. You can use Lambda methods and here method reference to reference the code as long as the signature is the same. Receive a pass information and return a string. Good? Good? And first, strategy. Second, template methods. We used to create a lot of template methods in the past. 2023, no template methods. We don't create template methods anymore. So how can we solve this problem? So if we go to template methods, before that, what do we have here? In this class, when you're integrating with Google Wallet, you always have to authenticate first, and then you need to sign the token as the last step. But depending on the type of pass you're creating, the operation in the middle is different. So here, always the same. Here, always the same. Here, always the same. Here, different. So what do? We create an abstract method and an abstract class. And we create concrete implementations depending on what we want to do. So if I want to create a loyalty pass, I create here, well, return a map saying I'm loyal. If I want to create an event ticket, I return a map with other information. This is the template method. This is what we used to do almost 30 years ago. In 2023, you shouldn't be creating template methods. You should be creating what? You should, instead of using template methods, you should be using the strategy design pattern. So here, instead of creating an abstract class, you create a class, and here is the part that is always the same, and the thing that changes now is a strategy. Okay, so you create again a field, which is a function that receives a pass information and returns a map of string. And how do you use it? Well, you can do this. When you create a new Google Wallet pass creator, and here it requires a function. So this function is going to receive a pass information, is going to return a map of generic or value. Okay, so let me hit an enter here. So instead of creating template methods, I do this. I pass implementation here as a lambda. Or, just like we did in the strategy, we can use method references for different types of methods. Okay? This is the modern version of template methods. Next one, singleton. This is easy. Most of you already know this and already use it, but just for the records, let's get here the singleton. Legacy singleton used to have a static final method called instance and a get instance method. You would always return the instance. You could even create a lazy initialization here. It depends on how you want to implement that, and this method would need to be synchronized. There are different variations. Since Java 8, the best way to create a singleton is to use an enum. Instead of creating a class, you create an enum, and with only one enum in it. So instance, the JVM always guarantees that it's a single instance, and you don't have to worry about serialization because this code is wrong. If you're using serialization, there will be more than one instance of this object in your JVM. If you're using this version, the JVM guarantees that there's always only one instance. So you don't have to worry about it. Next one, interpreter. I know this is very rare to use, and most of the examples are only from the book, but I want to show you how you can do different in 2023. So if I go here to the interpreter, the legacy interpreter, you can use enums for the operation, and based on the string that you're receiving, you would return one operation. Okay. And here you're using a stack to represent a calculator. So you can use this syntax, which is called reversed Polish syntax for operations. If you ever use an HP calculator, it's the same syntax. So if I run this method, it's 5 plus 7, 12, 10, 5 minus 5, 12 minus 5 is going to be 7. Let's see if I'm right. Seven is the result of this code. So what we can do with the new version is to change this. So what did I change? Since Java 8, instead of returning just value map, here, the operation. The operation from string is returning value map. So if it doesn't match an operation, plus or minus, it's going to return null. Okay? So how can we improve this? Well, we have this class since Java 8, which is optional, which allows us to return if there is a result or not. So I just create an optional here of nullable, because this value can be null. And here, instead of creating an if and else, I'm going to simplify this operation using the optional. So with an optional, I don't need an if else anymore. I can do this. So I can do operation from string s if present. If there is an operation, I can say all, evaluate, first part. Second argument is consumer. So if it's empty, I'm going to push. And I know it's complicated to see, but trust me, it should work. If it doesn't, we'll try again. Let's run. Oh, what did I do wrong? Luckily, I have here the code. Visited interpreter. And I don't know what I did wrong again. I'm going to just copy the code. Operation. And let's run. It works. Yeah, I did something wrong. Sorry. So yes, still 7. Okay, and this one is complicated to understand, but if you look at the source code later, it will become easier. So next one, chain of responsibility. This is a good one because the name is complicated, but we use it a lot of time in our code. Let me show you an example. So if we have the chain here, the user case here is I have a user notifier. Okay, and the user notifier interface is like this one. Either notifies, has a method to notify and a method to set the next one. And why is a chain? Suppose that I configured, I created an app and I created notification. So the user configures 3 different types of notification. They can have a Google Wallet notification on their wallet. They can have an email notification or an SMS. But you don't want to send all of them. You only want to send one notification to the user. Okay? So what do? You create a chain. So the first link in the chain tests, oh, does the user enabled the Google Wallet notification? Yes or no? If yes, I send and it's done. Or else I move to the next link in the chain, which is the email. If the user enabled it, I send it, it's done. Or else I move to the last one. And same thing, if the user enabled SMS, I'm done. Or else I move to the next one. I don't have a next one. The user doesn't want a notification. So this is a very common use case. I want to notify only once, but depends on how the user configured. Depends on each one of the users, how they configure that. So the legacy chain requires you to have this code in each link of the chain. Here, the Google Wallet pass update notifier. Method notify has to ask, user profile has Google Wallet pass? If yes, okay. Or else, move to the next one. If not, if you don't have a next notifier, runtime error in this case. Okay? Email, same thing. Does it allow email? Send email. Or else, move to the next one. SMS, send a SMS, or else, send to the next one. So this logic is complicated and very easy to miss because you have to copy-paste the logic every time. And how do you compose your chain? You have to do this. I have to create the Google Wallet pass update, the email, and the SMS. And I have to always create, this one is the first, this is the second. And the second, this is the next one. And if I want to change the order, I have to modify this code to always set next, next, next. The new version, The revisited version of the chain of responsibility is much simpler. First, instead, if you look at this code, this legacy code, the problem with this code, besides copy and pasting, is that it does too much. This piece only tests if it's enabled or not. In the JDK, we have an interface that does that, which is predicate. Predicate tests a condition and returns true or false. And this next one is verifying if I should go to the next one or not. So this is and this is the implementation that is different from each one of the classes. So this code is doing too much. So the new version of the revisited version, we can do better. We can do this. We can create two different versions of this. First, I can create a class for the link, and it can implement consumer and a predicate. Because that's the two things that the code is doing. It's testing if it's enabled, and if it's enabled, it's doing something. So that's why I have a consumer and a predicate. The second option is to create a record with a predicate as a parameter and a consumer as a parameter. I don't know which one is best, but the two are possible. I'm just going to use this version today, but because that's the one I chose, but both work. So here I have a user profile, which doesn't want Google Wallet, wants an email, and doesn't want an SMS. So what we're going to do, and me as a programmer, I want this order. I want Google Wallet, email, and SMS. So what do? I can create a stream. When I create a stream, I can create a Google Wallet pass update. I can create a new email notifier and a new SMS notifier. This is my stream. Okay? And for each one of them, I can filter. Well, I have the notifier, and the notifier is going to test the user profile that I just received. And if it's notifier, and for each one, actually notify, find first, if present. Okay, I have to speed up. So I'm going to copy this code, or else I'm going to miss some of them. So what did I do here? This one I can type. New wallet pass updater. Okay, so this one. Oops. Yes. So here, at the first step, I'm filtering if the user has it enabled on the profile. I find only the first one that is enabled. And when I find it, I check if it exists. I call the consumer methods on it. And in this particular code, if I want to change the order, like I want the first one to be the SMS, I just have to come here and change the code. One line of code to be changed to change the order. In the old version, it's hard because I have to keep setting the next notifier. Okay. And move forward here. So this is the revisit version of the chain of responsibility. Next one, visitor. Visitor is a very interesting one because it's one of the most complicated design patterns. Actually, when I first learned about the visitor, next day, I went to the office and I try to find somewhere in the code to use the visitor, just to show my colleagues that I was smarter than them. But visitor, it solves a very specific problem. It's a very elegant solution, but it's very hard to read. Okay? Another reason for you to use the visitor is that you have an operation that varies by type. This is the strategy design pattern. Okay? I have here a hierarchy. For example, with Google Wallet, I have multiple different types of passes. I have loyalty cards, I have event tickets, and I have more. And I have different ways of doing things if it's a loyalty card and if it's an event ticket. In this part of the system, you want to vary the operation based on loyalty card and event tickets. In this other part of the system, you want to vary the operation based on loyalty cards and event tickets. In a third part of the system, you want to do the same. If you only had one operation to change, you would create a strategy, right? The problem is that you have multiple operations that change depending on the same type. You can't solve with strategy anymore. The only solution, the only good solution is a visitor. Okay? Other benefits of the visitor is that if you're creating a strategy, the code of the strategy will be inside loyalty cards and event tickets. Okay? So loyalty card is here. This other module is here. The code from this module will be inside this class, loyalty cards and event tickets. And the code from the other module will be here as well, loyalty cards, event tickets, if you were using strategy. So the visitor is good because you want to vary the operation, loyalty card and event tickets are here, but the code for this module stays here. And the code from this other module stays here. So the visitor is good when you want to keep the code for your module in your module, instead of having to couple this module with the classes from the other one. Okay? So this is a good thing. You increase cohesion and reduces coupling. So visitor is good for this, but visitor is very hard to read. Another benefit of the visitor is that, well, that's how you implement. You create a visitor, you create an interface visitor, and you create a method visits for each one of those subtypes. I have here abstract class, Google Wallet Pass, loyalty card, event tickets. And another benefit of the visitor is that if you create a new class, generic pass extends Google Wallet, and you have to implement these methods. Visitor.visit this. If you create this class, you have a compile time error. Your code doesn't run anymore until you implement these methods here. And once you add it, you have to go in all the places in your system that is implementing the visitor and add the method. So the good thing about the visitor is that it gives you compile time safety. If you change the visitor, your code will break. It's a good thing. You have to change everything so you don't get a runtime exception. You have a compile time error, which is much better. So let's fix this problem. I have to implement visits, generic pass, and we're done. This is how we used to do visitor 20 years ago. In 2023, We have this modern version of the visitor. So what can we do here? I have a class. Oh, actually, I already have the solution here. But what we did here, let me comment this one. Event tickets. In the past, we used to create just an abstract class. And with Java 20, and soon Java 21, what we can do, we can create now what we call sealed classes. Okay? But before I dig into sealed classes, I want to show here that with Java 20, we're enabled to use pattern matching on the type. Okay? In the past, I would need to do if pass instance of loyalty. Okay? Which is a bad thing. And now we can use pattern matching here in the pass. So if I have a case loyalty card, loyalty, I want to return 5. Case event tickets, I want to return 10. And that's it, right? Should be it. But I have a compile time error. Why is that? Because I didn't cover all the possible use cases. So I'm forced to do a default. Default throw new runtime exception. The problem with this code is that it gives me a runtime exception and not a compile time error, which is the benefits of using the visitor. How can I fix this? Well, with Java 20, I can use sealed class. So I can create an abstract sealed class and permit only loyalty and event tickets. So I don't need the default anymore. And if somebody creates a subclass, generic class creates another subtype, I have a compile time error. Well, this code doesn't compile because the sealed class doesn't permit these children. So, and if I change the code here, generic path. If I add here, now what do I get? I get a compile time error here, which is the implementation of my visitor. So what do I need to do? I need to add generic pass. G turns 8. And even better than that, now I can use a visitor not only based on the type, but I can also do that based on the state of the instance that I'm receiving. So case loyalty L5, I can say case loyalty L when L.size bigger than 5. It's going to be turned 6. Okay, so I can create these things, and when else bigger than 2, it's going to return a 7. So I can create a visitor not only based on the type, but also on the state of the instance that I'm receiving. So much more flexible. You don't have to create an additional if. You can have different implementations of your codes. Remember, this code is simple, but you could be creating like method references and all this sort of stuff here with visitor. And last but not least, the specification. How does the specification work? Specification is the design pattern from domain-driven design. And if I find here, specification here. In the past, for us, it's good for us to give names to conditions in our system. Because we would be, I want to verify a credit card number. Okay? potential credit card number. So instead of creating an if, s dot, if, let's say, string s card, ABC. And instead of doing if card.length equals to 16 and card.matches only digits. Okay? 16 is a magic number. And this regular expression is a magic condition. You don't know what it means. Okay? And you write this today, good. 6 months from now, you don't remember what does this mean anymore. So instead of adding comments to your code to document these expressions, it's a good thing for you to do this. Well, the name of the condition is the right length. So if it is 16, I know it's the right length. Okay? And if it matches only digits, I know that it's numeric. So for my condition to be a potential credit card number, it needs to be the right length and is numeric. And if I had other things, I would just say, and other things, this is the specification. It helps you to maintain your code. Now your code is self-documented. Okay. For us to be able to do this, we needed to create this interface specification. It's exactly like the book. So it has one Boolean is satisfied by, and it has the AND condition, the OR condition, and the NOT condition. Okay? And I had to create additional classes. Here I have a record AND specification, OR specification, and NOT specification. This is what we used to do 20 years ago. Now in 2023, we don't need to create the specification classes anymore, because in the JDK, we already have a class called predicate that implements the specification for us. If I go to predicate, predicate already has the AND, the negate, the OR, is equal, has a lot more than we needed in the original specification. So if I wanted to create this today, I just needed to create a predicate string, like is right length. And I just say, well, I receive a string, s.length equals to 16. Good. And predicate string is numeric, s.matches, only digits, n is right length, and is numeric. Okay? There's another specific use case when I want to create queries that I send to another system using specifications. We can do that using pattern matching, but I won't be able to cover with you today. Okay? And if you like this code, I know that it might be a lot of information. All the source code is available on this GitHub repo. So now is the time for you to take a picture and share on Twitter. And my username is @Yanaga. And I don't know if you have time for questions.
Yeah, that's right.
1 minute.
Super.
Okay.
それでは会場の皆さんで今ご質問のある方ありましたらおっしゃってください。日本語でも大丈夫です。通訳しますので。大丈夫ですか？
使った理由を教えていただきたい。
about the VAR. Is there any reason to use VAR declaration instead of specific type declaration?
Oh, yes, there is a good reason. Because if I use type declaration, it wouldn't fit in the screen. So that's the main reason. Okay. So that's
great.
yeah.
よろしいですか？ありがとうございます。
So you only use it in a slide or a presentation, or do you use it in a production code?
No, I use in production code when it doesn't matter for me which type I'm using. Okay, but that's what I do. Personal preference. Right? If you're declaring here and you're using immediately in the following lines, okay, var is good because you can see, oh, it's this type and I'm using this one. If you're declaring here and using 5, 6 lines below, then it's bad because it's much easier for me to just go over and see what type it is. But I also understand that if you're using any ID these days, it really doesn't matter because you just pass your mouse over the type, the variable, and it already gives you the type, especially if you're using IntelliJ IDEA. So for me, I think it's just a matter of preference. Right? And if the type is too big, like if you're using Spring, if the type is too big, sometimes using var is good because, or else the line is way too big.
よろしいですか？他になければおしまいにしますが、よろしいですか？ Thank you, Edson, for your great presentation. 拍手をお願いします。
はい、ありがとうございます。